Hello friends. A Brief History of Time by Stephen Hawking contains 12 chapters. In this video we are going to know about the summary of the book A Brief History of Time by Stephen Hawking, from chapter 1 to 6. Chapter 1, Our Picture of the Universe. The first chapter of A Brief History of Time explores the history of scientific thought about the universe, from Aristotle to Isaac Newton. Hawking explains how each of these thinkers built on the work of their predecessors to create a more complete understanding of the universe. Hawking discusses the geocentric model of the universe, in which Earth was considered the center of the universe, and the heliocentric model, in which the Sun was at the center. He then moves on to the idea of an infinite universe, which was proposed by Thomas Digges in the 16th century and supported by Galileo in the 17th century. Hawking explains how the development of the laws of motion by Newton and the discovery of gravity allowed scientists to understand the motions of the planets and other celestial bodies. He concludes the chapter by introducing the concept of relativity, which was developed by Albert Einstein in the 20th century. Chapter 2, Space and Time. The second chapter of A Brief History of Time explores the nature of space and time. Hawking begins by explaining the difference between classical physics and quantum mechanics. He then introduces the concept of space-time, which combines the three dimensions of space with the dimension of time. Hawking explains how the speed of light plays a central role in the nature of space-time, as it is the fastest speed at which information can travel. He also discusses the concept of causality, which is the idea that an effect must always follow its cause. The chapter concludes with a discussion of the expanding universe and the Big Bang theory. Hawking explains how the universe is not only expanding, but also accelerating in its expansion. He also discusses the idea that the universe began as a singularity, a point of infinite density and temperature, which expanded rapidly in the Big Bang. Chapter 3, The Expanding Universe. In this chapter, Stephen Hawking discusses the concept of the expanding universe. He begins by explaining how the discovery of the redshift of light from distant galaxies led to the idea that the universe was expanding. He then goes on to describe the different models that were proposed to explain the expansion, including the steady-state theory and the Big Bang theory. Hawking explains how the discovery of the cosmic microwave background radiation provided strong evidence in favor of the Big Bang theory. He also discusses the idea of inflation, which suggests that the universe underwent a period of exponential expansion in the first fraction of a second after the Big Bang. Hawking concludes the chapter by noting that the discovery of the expanding universe has profound implications for the nature of the universe as a whole. He suggests that the universe may be infinite in extent and that the laws of physics may be the same everywhere. Chapter 4, The Uncertainty Principle. In this chapter, Hawking discusses the principle of uncertainty, which was first introduced by Werner Heisenberg in the 1920s. He explains that according to this principle, it is impossible to know both the position and velocity of a particle with complete accuracy. The more accurately we know one of these properties, the less accurately we can know the other. This principle has important implications for the behavior of particles on a quantum level, which can sometimes behave in unpredictable ways. Hawking also discusses the concept of wave-particle duality, which describes how particles can sometimes behave like waves, and waves can sometimes behave like particles. He explains that this duality is related to the uncertainty principle, as particles that are localized in space have a well-defined position but an uncertain velocity, while waves that are spread out in space have a well-defined velocity but an uncertain position. Chapter 5, Elementary Particles and the Forces of Nature. Hawking discusses the fundamental particles that make up the universe, including quarks, leptons, and bosons. He explains that these particles are the building blocks of matter, and that the interactions between them are mediated by four fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Hawking goes on to explain that physicists are still working to unify these four fundamental forces into a single theory, known as the theory of everything. He discusses the challenges involved in this quest, including the fact that gravity behaves differently than the other three forces and has not yet been successfully incorporated into a unified theory. Overall, these chapters explore some of the key concepts in modern physics, including the uncertainty principle and the nature of particles and forces. Hawking's writing is accessible and engaging, making these complex ideas understandable to a broad audience. Chapter 6: Black Holes Ain't So Black. This chapter provides Black Holes Ain't So Black. Hawking discusses the nature of black holes, which are objects in space with such intense gravity that not even light can escape their pull. Hawking argues that despite their ominous name, black holes are not entirely black, as they emit radiation in the form of particles that are created at their event horizon, the point of no return where anything that falls in is irretrievably lost. This radiation, which has come to be known as Hawking radiation, causes black holes to slowly evaporate over time, and eventually disappear. Hawking explains that this discovery has profound implications for our understanding of the universe, as it challenges some of the basic assumptions of classical physics. For example, it suggests that the laws of physics may not be deterministic, since the information that is lost when something falls into a black hole cannot be retrieved, even in principle. This raises questions about whether there is an ultimate limit to our ability to understand the universe, or whether there are fundamental limits to what we can know about the world around us. Summary from chapter 7 to 12 will be available in next video. If you like our content, please like, comment, share and subscribe to our channel.